So we finish this introduction today, and then maybe next meeting we're going to have potentiometry, and most of the topic that we have, we will go back, okay, especially when we go to this what we call electrodes. So if I'm not mistaken, we finish on this standard electrode potential, and we end up here, if I'm not mistaken. So this is the so-called reduction potential. Okay, so this is not new to you, but the way it was built is you. Okay, there you go. Ilang porsyento na lang to. Okay, 100%. So if you're going to look at this reduction potential, all of them were matched with SHE. So if we're going to interpret this one, okay, so what can we say if we're going to ask what's the relationship of zinc versus the cadmium? Dali yung madaling ma-oxidize. So if you have a cadmium and a zinc metal, okay, so what does it mean? If we dip zinc in cadmium 2 plus, will there be anything that will happen? If we dip cadmium metal in zinc 2 plus, will there be a reaction that will happen? So paano yung pag-interpret natin sa table na ito? So anong masasabi natin dito? Which is a strong oxidizing agent?
Yung cadmium 2 plus po, sir.
So this is a strong, or we could say the one that you have here are the strong oxidizing agent. And the one you have on this side are what? The reducing agent. So the way that we look at this, so alin yung mangyayari dito? Zinc in cadmium 2 plus solution or cadmium metal in zinc 2 plus? Okay, so when this happens, usually you expect your zinc to dissolve and you see a deposit of your cadmium metal in the electrode. So we could say zinc is more easily oxidized than the cadmium. So it's just like the principle that we have doon sa discuss ko sa event last Friday. So when you have zinc and an Fe, okay, so between the two, this one will be more oxidizable or will oxidize compared to this one. So when they form, okay, when it oxidizes, it forms a zinc 2 plus and oxide, that's form an additional layer. Now for this one, okay, this will not happen. So we could say this reaction is non-spontaneous. And how do you make it happen?
Provide energy.
You have to apply energy. Okay? Now, in addition to that, what if we're going to compare Fe3 or Fe3 plus, Fe2 plus, and the iodide and the triiodide. So which one is a better oxidizing agent?
Fe3 plus po.
Let's say if we're going to compare this versus the triiodide. So if we're going to look at this, okay, so this is an Fe3 plus, and this is the triiodide. So we could say, on the other hand, you have the, what is this? A more reduced form, okay, on this one. So this is a better oxidizing agent. So if we're going to have this in a solution, which one will dominate? So if we put all of this ion, okay, in the solution, so that means we're going to react them. So in that case, how will be the reaction? So maybe your Fe3 plus will react, okay, with the iodide. And this would form Fe2 plus and the triiodide. Am I right? Because this
Yes,
one
po.
will become what? Hindi naman sila parehong nandoon yung electron sa reactant side. So one of them will have to reverse the reaction. So ano mangyayari? So this one will become on that side, and this one will become there. So we could say the one that will dominate will be the Fe2 plus and the triiodide. Kasi mako-convert sila. Does that make sense?
Yes po.
Because remember, this one will remain like this, right? Kasi siya yung more reduction and reduction potential power. Okay, higher reduction potential. So this one will undergo oxidation. So in the end, this will be converted to this species. So ang magdo-dominate is yung Fe2 plus tsaka triiodide. Ganun yung ano dun, interpretation based on this one. So those are the questions that you might have in your quiz. Okay? Now, if we're going to look at the what we call the electrode potential, okay, there are other things that may affect the system at equilibrium. Okay? So for instance, hindi lang yung species na yan ang nag-undergo doon sa equilibrium na yan. So if we're going to look at the SHE, the application of the standard reduction electrode potential is further complicated by solvation, dissociation, association, and complex formation reactions involving in the special species of interest. So these are what we call organic chemistry as side reaction that is happening. Okay? So for example, dito sa case ng iron 3 and iron 2 couple, there are some complex formation, okay, that is being observed. So the effect of other equilibria systems. So for this one, we could say we can look at the different potential of this iron electrode. I'm trying to look at my notes. So this side reaction can affect the standard potential that you have. So for instance, if you have Fe Fe3 plus with one electrode, okay, it produces Fe2 plus. So the same thing with another one. So what changes? So they found out that at different acid, they have a different potential. So for instance, this has a potential around plus 0.73 in 1 molar perchloric acid. And then this one has a potential around 0.70 in 1 molar HCl. And then Fe3 plus electron producing Fe2 plus, it has a potential of around 0.60 in 1 molar of phosphoric acid. So as you're going to see here, the presence of other species can have an effect on the standard electrode potential. Okay, so these are some of the things that they have. So in 1 molar perchloric acid, okay, they found out that the electrode potential of Fe3 plus going to Fe2 plus is around 0.732. And if they substitute hydrochloric acid for the perchloric acid, this goes to 0.70. And if they use phosphoric acid, okay, it goes down to 0.60. Now, we could say here, the changes is not really big, but this one, okay, the changes is, we could say, so big. But what really the reason why you observe this one? So you have what we call some side reaction that can affect this one. So anong meron sila dito? So maybe the Cl minus can react with Fe2 plus and Fe3 plus to form what? Complexes. Okay. And this would affect the net activity of the electrode. Okay. So remember, we're talking about now here that it is more on the activities, not the concentration, that affect the standard electrode potential. Okay. Now, furthermore, if you have what? A phosphate. Okay. Phosphate from your phosphoric acid, you could say that there are complexes also that form peric phosphate or perus phosphate, and this further affect the net activity of your Fe2 plus and Fe3 plus. Okay, so the actual concentration there of your uncomplex. So ano ba yung mga uncomplex iron natin dito? Usually the Fe3 plus and Fe2 plus that doesn't form what we call or doesn't react with the thing. I'm not sure. I think if you're teaching Gen Chem, remember the ginagawa niyo pa ba ito diyan? Hindi ko alam kung ginagawa na. The iron thiocyanate reaction. So usually what you do when you have this reaction, ano yung color na nagpo-form?
Blood red po.
Okay. So ginagawa pa niyo yan sa Gen Chem?
Qualitative na lang po, sir.
Okay, yeah. And if you could see, if you're going to add like a phosphoric acid to it, ano nangyayari? Okay? Hindi siya nagiging blood red. What happened is either light color or colorless, because what happened, okay, the phosphate will compete with the SCN. Okay, so walang nagpo-form na FeSCN. Ang nagpa-favor is yung backward reaction because the Fe3 plus is being utilized by the phosphate. So the same thing that is happened here. So there's a complex formation, okay, of the ferric and ferrous phosphate. So it will have a net effect, okay, doon sa potential. And this is the only, we could say, one that is studied, this one. So if this happens in Fe, so it's possible that it can also affect the electrode potential of the other, we could say, species, depending on what is present there. So there's a solvation, dissociation, association, and the complex ion formation. So we could say this is just one of the limitations if you try to look at the standard reduction potential. Okay. Now, they said to compensate for the activity effects and the errors resulting from this, what we call side reaction, just like the given examples I have. So Ernest Swift in 1939 proposed substituting a quantity and called it the formal potential. Okay, so if you're going to look at this formal potential, it's, we could say, compensate for problems with standard reduction potential or standard electrode potential using activity and the side reactions in place of the standard electrode potential in redox calculation. Okay, so this is based on the conditions of 1 molar. So the formal potential of a system is the potential of the half cell with respect to the standard hydrogen electrode when the concentration of reactants and product are 1 molar and the concentration of any constituents of the solution are carefully specified. Okay, and what they found, it has better agreement than the standard electrode potential with experimental data and the Nernst equation. So that means the conditions need to be similar to conditions where this standard electrode potential was measured. Okay. So the calculation of this, no, not that one. So using this formal potentials, so they found out that using formal potentials with the system different only in the composition and concentration of the electrolyte, it can lead, okay, to errors greater than those produced by using standard potential. So although initially they found out that, okay, I think this is much better when they look at the formal reduction of the Fe3 plus. Okay, just the example that we have earlier, 0.73 and 0.70 in those acid. So when they use this value in place of the standard potential in the Nernst equation, it yields a better agreement, okay, between the calculated and experimental, we could say, data or potential that they got, okay? But however, they found out that it can differ significantly in composition and concentration of the electrolyte, and it leads to greater error. Okay? Kaya hindi rin siya nag-work. Okay? We still stick to what we have at present. Okay? So they try to say, so how do we get this problem with regards to side reaction and activity effect? So initially they thought, based on the calculation, it works perfectly well, but if they put it on the system different significantly in composition and concentration, it's not applicable. It has a greater error. Okay. So from that, we could say if we do a calculation of the cell potentials from the electrode potential, so the way that we do it is through this cell equals to the cell potential of the cathode minus the cell potential of the anode. So the calculation of the potential obtainable from a galvanic cell or the potential required to operate an electrolytic cell. So ano lang yung difference dito? If you have a galvanic cell, this one will become what? The value. Positive. And if you have an electrolytic cell, this one is negative. So if we consider the calculation here, hypothetical cell, okay? So which one is the cathode here and which one is the anode? So this is your anode, this is your cathode. So if you're going to look at the cell, okay, activity is equals to 1. So we could say, we can assign the value here of your cathode as point. Still remember what it is? 34. And then this one is negative 0.76. So you end up with 1.1 volts. And this is a positive, which tells us this is a galvanic cell. Now, what if it's this one? What will happen? So you're going to switch. So this is the anode, this is the cathode. So in this case, you have 0.76, okay, minus, what do you have? 0.34. And you will have here so how do we make this reaction proceed? We need to apply more than 110 volts, or not really negative, but around 110 volts. I think this is the last one. Yep. So that's how we end up with the present thing that we have. And I think this is the last time we're going to have this one. Although when we go to potentiometry, we're going to look at the reaction that happenings in the electrode. Okay. So the next thing that we're going to do is currents. So far, okay, only one general type of measurements of electroanalytical method is based on the measurement based on the absence of appreciable current. Okay, potentiometric method, they don't have current. But the other methods that we have, okay, the electroanalytical method like the voltammetry, electrogravimetry, okay, we're going to discuss current for this. And as noted earlier, electricity is carried within a cell, okay, by the movement of ions. And usually, this is what can we say about this Ohm's law? One of the most fundamental electrical relationship. So in the Ohm's law, what is E here? This is your potential difference or voltage. I is your current, and R is your resistance. And resistance depends on what? Nature and concentration of ions in the solution. Have you seen this before? How to illustrate Ohm's law? First time you ba nakita to? So Ohm's law, okay, serves to define the unit of resistance as well as the resistance itself. 1 ohm of resistance is the resistant presence when 1 volt of potential is required to cause a current of 1 ampere. So volt is the one, we could say, pushing the current, while resistance is the one, how do you say it? Slowing the flow. Okay. And electrochemical methods of analysis are based on the measurement of one or more of these values. Okay. Now, why is Ohm's law included here? Okay. Because Ohm's law has the ampere. So when there is a direct current in an electrochemical cell, the measured cell potential is usually different from the thermodynamic, I think I have this, okay, the theoretical thermodynamic calculation, okay, and this difference can be attributed to a number of phenomena, including this ohmic potential and several polarization effects, such as charge transfer, polarization, concentration, polarization, diffusion, over voltage, and crystallization over voltage. Okay, so I'm not sure. Have you discussed this in Chem before? Like, meron kayong mga, oh my God, yung mga oh shoot, come on. Trying to draw something here, and then you have here like this. Ano ba yan? Was this discussed to you before? Yung paano yung magsulat ng electronics? So usually this is what?
Chem, sir.
Saan?
Hindi po sa Chem, sa Physics 13
Sa
po
physics? Yeah, I think si Sir Micor lang nagaganito sa 137 noon eh. Okay, so usually this is what? The positive, negative, and this is your E. And then you have here like an R. And then there's some sort of an I. Okay. So the way that you get the current is just equals to what? Since E is equals to IR, so I is equals to E over this what we call resistance. Okay. So the way that we look at this is what is the effect of the current on the cell potential. Okay, so remember, this one that we have are what? Thermodynamic values. So these are usually what? At equilibrium, may current or wala? Okay, at equilibrium, usually there's no current. Okay, but in practice, they always find that current is always present. Okay, so what does the current do? What would be the effect of the current in the what we call cell potential? Sa galvanic cell, ano sa tingin nyo mangyayari sa current? Anong effect sa cell potential ng current? Anong effect nito? Current would, what do you think? Decrease or increase in galvanic cell? And if you have an electrolytic cell, what do you think happened to the potential? Sige nga. Wala akong tubig. Try to think. Yung iba. What do you think happened? Okay, what will the current cause in the measured potential for the galvanic cell and the electrolytic cell? So if you listed the potential, the electrode, usually they said it's a thermodynamic values. Okay, so at equilibrium, what does it mean? There's zero current. There's no current. However, in practice, they said current is always, we could say, present. Okay, so what do you think will the current cause the potential that you have? So si Rain lang ang may sagot. How about yung iba? So current, they said, causes a decrease in the measured potential for galvanic cell. Okay, and it causes an increase in the potential needed to drive electrolytic cell. Okay, and what we're going to discuss today is the two main sources of current effects on the cell potential. So one is the so-called ohmic potential, or the so-called IR drop. So this IR drop pertains to current resistance drop. Okay? So they said the ohmic potential, to develop a current in either a galvanic or an electrostatic cell, you need a driving force in the form of a potential that's required to overcome the resistance of the ions to movement toward the anode and the cathode. This still follows, we could say, the Ohm's law, and is equals to the product of the current in amperes and the resistance of the cells in ohms. So that's where we get this IR. Okay. So the net effect of the IR drop is to increase the potential required to operate an electrolytic cell and to decrease the measured potential of a galvanic cell. So that's where I base the answer to the question that I asked. Okay, so E that is applied equals to E of the cathode, E of the anode, and then the IR drop. So when we look at this ohmic potential or IR drop, it's just the flow, okay, of ions or flow of current through a solution, okay, which gives potential across a cell according to the Ohm's law. So the flow of ions, so that's you have the ions there, that's your current. Where do you think the resistance came from? the flow of ions through solution. So the resistance would come from the solution. Okay, that gives potential across cell according to the Ohm's law. So that means this IR drop, you're just going to subtract it really from the cell potential to get the true potential of the cell. Now, for us to understand this, let's try to solve a problem. So the following cell has a resistance of 4 ohms. So calculate its potential when it is producing a current of 0.1 ampere. Okay. So if we're going to look based on this one, this is your anode, this is your cathode. It should be there. So if we're going to look at the cell potential of this, so you have what? E cell equals to, so let's say you don't know the thing here. So this is what? E cathode minus E anode. So for the E cathode, I would say I have 2,8. And I have here, I think I give you the 3 bar, 278. And then you have here negative 462. So ano yung cell potential niya? Let's see if the potential really drops. Yes, Carmel.
Sir, question lang po, yung IR drop po ay nakaka-affect din sa inot cell or sa E cell
Yeah.
lang po?
Sa ano, sa cell. Maybe we don't put this one. Kasi parang 0.1. Ano lang, yung sa cell lang. So we want to see what is the real potential if we have the IR drop. So kapag wala yung IR drop, ano meron tayo dito?
0.74 po. Pag walang IR drop.
Okay, so that will be the value here. Ano ba yan? Right? Now we put the IR. So that is equals to what?
0.34 po.
Minus times 4. So this will be less, right? So you have what? Bayan. So this is just showing you the effect if you have current in the system. Because di ba sabi ko, current, the presence of current causes a decrease in the potential sa galvanic cell. So this is an example. So without the current, the IR drop there, ito yung potential niya. But if you consider the presence of the current there and the resistance, na-decrease yung value niya. This is never, we never took this in, I think, a Chem 1. Or even in, I'm not sure, electrochemistry, sa analytical. But I'm just showing you here how the effect of the IR drop or the ohmic potential in the what we call overall cell potential. So if you're going to look at this, paano natin i-ano to sa isang system na similar doon sa voltage. Di ba they said that Yun sa flow of water. So the flow of water is synonymous to what? The current, right? Mag-aano yung flow ng water kapag itataas mo yung potential. So parang itataas mo yung potential difference nung hose mo para mag-flow yung water. Now, usually, when water flows to the type, anong nangyayari? There is some sort of resistance. Okay? So, if there's a resistance, there's a pressure drop. Okay? And this pressure drop is similar doon sa voltage drop that occurs across what we call a resistor kung meron kang electrical circuit. Kasi sa electrical circuit, yung resistor, yun yung resistance mo. Okay? So question? And then I have another one. So calculate the potential required to generate a current of 0.1 ampere in the reverse direction of the cell of the previous example. So baliktad naman to. So ano ina-expect mo dito? So initially ano yung ano natin dito? 0.740, di ba? So ibig sabihin, kapag tinignan natin yung potential dito, that will be negative 0.740. Am I right? So if we're going to look at this one, so this is the cell. So if we're going to look at this E cell, tapos yung kung ano man yung potential, tapos meron kang IR. So ano ngayon yung potential na makukuha mo kapag meron kang current of 0.1 ampere. So this is what? Negative 0.740. You don't know this. And this is the same thing, 0.1 and 4 ohms. And what do you do? Oh no, I think the one that's given there, this is the point, negative 0.740. So ano ngayon yung anong potential if you apply it with the current? So this is depicting that the potential will be higher, at least in magnitude. So ano yung makukuha mo? Negative 1.08, 0.74 minus 0.1 times 4. This is 0.4, di ba? Isn't it this one? So you might say negative. This is what? Smaller. But remember, the sign here is just telling us if there's an energy that is generated or energy that you need to apply. So I'm just trying to show you here proof based on the answer that I have here that in galvanic cell, okay, the potential goes down if you apply current or if you have a current, and in an electrolytic cell, the potential goes up. Okay. And that brings us to the next one that causes what we call current effects on dissolved potential. So the next one is what we call the polarization. So nauna ata yung handout ko dito. So, how could we define polarization? Anyone? In real life, they said polarization is happening right now. Ano yung polarization na nangyayari sa atin sa real life? Here in the US, it's common. I don't know there in the Philippines. So when you say polarization, the people are polarized. So parang divided. Okay. Now, in electrochemistry, you can also apply the term polarization. Okay. So it's certain mechanical side effects that occur at the interface of the electrode and the electrolyte. So they said polarization is some sort of a mechanism that typically results in the change in the potential of an electrode during electrolysis, where the anode's potential becomes nobler than that of the cathode. Okay, so polarization can occur at the cathode, you call it cathodic polarization, or at the anode, you call it anodic polarization. And in most cases, polarization can cause a decrease in the output of voltage, especially when you're talking about batteries, and an increase in the voltage required for electrolytic cells. Okay, so we could say this is what different to the effect of the ohmic potential. Okay, where current decreases the galvanic cell and increases the potential for the electrolytic cell. Okay, now we could say, if we look at this polarization, nagkamali lang yung ano ko handout dito. Or nawala yung isang handout ko. There should be one handout, one slide that I have. I think I erased it. So if we're going to look at this polarization, okay, they usually use the so-called current versus potential curve. So that's why I have this, the current and the what we call potential curve. So at high or low cell potential, you can get a less positive or negative current than expected. And this is due to the so-called polarization. Now, why is it happening? Well, the solution or reaction cannot keep up with the changes in the potential of the system, and it limits the rate of the reaction. Naka-hide. Ganon. Kita niyo sa ano? Bakit kaya? I have to tingnan ko nga yung original. Nandun nga. 52. Paano siya na-hide? Anong ginawa ko? Ulitin ko nga. Discard. Ayun. Naka-hide. Now I see. Thank you for that. Nawala tuloy yung ano ko. Momentum. So, in several important electroanalytical methods, we always measure the current in a cell as a function of the potential and construct current versus voltage curves from the given data. Okay? So, the one that we have earlier predicts a linear relationship between the cell voltage and the current at constant potentials. However, okay, current potential curves are frequently non-linear at the extremes. Under this circumstance, we call this a polarized cell. Okay, and the term polarization, we could say, refers to the deviation of the electrode potential from the value predicted by the Nernst equation on the passage of the current. So parang ano lang yan sa spectrophotometry. Kapag the Beer-Slow plot, so usually pag mataas na yung concentration, they already deviate. Okay? So, yun yung tawag na polarization. So, if you're going to look at the polarization, so usually, if we follow the Nernst equation, okay, dapat ito yung susundan niya. But, when polarization happens, so that you see the deviation, okay, of the plot that you have between voltage versus current. Okay, so usually the cells exhibit nonlinear behavior at a higher current exhibit polarization, and the degree of polarization is given by the over voltage or the over potential, which is symbolized by this one. So you could see, you can include there the cell, the ohmic drop, and the over potential or over voltage. Now, the factor that influence this polarization, okay, we can include here the electrode size, shape, and composition. The composition of the electrolyte solution, okay, the temperature and the stirring rate, the current level, and the physical state of the species participating in the what we call cell reaction. Okay?
Wala pong slides.
Wala slide. Ay,
Wala
teka.
po kayong nakashare.
Na-hide ko nga, hindi ko naman na. Magsalita kayo. Okay, so as I have told you, polarization happens when there's a deviation of the current versus voltage curve. Okay, and usually this deviation is away from those predicted by the Nernst equation. Gaya nga dito. And if you have this polarization, what it do is it exhibit nonlinear behavior. And there are some factors that affect this polarization. These are just some of them. Okay. And we can always look at this in terms of this one. So kapag meron kang polarization, so you have here what? So ito naman yung kabaliktaran. You have a voltage and the current. Okay. So if you're going to look at this, so you expect it to behave linearly, but when it arrives here and here, so you expect already some deviation that is caused by polarization. Okay. Now we could what we could look at these sources that contribute to polarization. But first, we can define yung tinatawag nating ideal polarized electrode at yung ideal Non-polarized. So this should be non-polarized. So if you have an ideal electrode, this is one in which the change of potential over a fairly wide range has no effect on the current that flows to the electrode. So if you're going to look at an ideal polarized electrode, ganito yung plot niya. Okay? So there's what we call no net effect of the current that flows through the electrode. And these electrodes are typical, or we could say are useful, because they do not undergo what? Pag ganito. Wala siyang redox reaction. Okay? So they are, we could say, inert, which makes them a good choice for studying the electrochemical behavior of the species. So what do you think the basis for this one? Yung CB. Okay, yan yung principle behind yung cyclic voltammetry. Now, yung ideal non-polarized electrode, this is the one in which a change in current has no effect on the electrode's potential. Okay? So between the limits defined here by the red line, okay, with deviation shown by the dashes here, okay, so this type of electrodes are useful because they provided a stable potential against which we can reference the redox potential of the other species. So this is where you use it for the stripping analysis. So you find the potential where it's going to generate current. So you're going to apply that certain potential and then look at the current that you have. Okay. So where does the polarization happen? Here. Because that's where, okay, you will see the deviation that they have. Okay. Now, we can add to this one the other polarization phenomena that happen. So we can categorize it between a concentration polarization and kinetic polarization. Okay, so between the two, when we have a concentration polarization, it happened because of the finite rate of mass transfer from the solution to the electrode surface. So why do you think it happened? Okay, because there's a presence of species that you have there. So the reactant species do not arrive at the surface of the electrode, or product species do not leave the surface of the electrode fast enough to maintain the desired current. And again, okay, this type of polarization is dictated by diffusion, migration, and convection. Tandaan niyo pa to? Tandaan niyo pa yan?
Yes po.
You still know the difference between them, although I think I put the thing here that why this concentration polarization happened. Okay, so it's due to the slow mass transfer. Now this mass transfer could be what? Difference in the concentration, which is diffusion. Okay, difference in the potential, what is migration, ions move in potential, or mechanical steering, which is convection. Okay, so that's happened to this what we call concentration polarization. Now, if there's a slow immediate reactions that happen, we can have this so-called reaction polarization. Okay, and if there's a slow transfer of electron between the electrode and the species, we can have this so-called charge transfer polarization. And I think I have this one. So what do we see here? How many regions do we see here? Because this thing that happened here, the combination of the process. So how many regions do we see here? Ilang region? Isa, dalawa, tatlo. So you see here 3 regions of a half cell reaction. So we could say this is what? An electrolytic cell, because this is where polarization can occur. So this region includes the electrode itself, the surface layer, okay, or a surface film of solution immediately adjacent to the electrode and the bulk solution. Because you might say, di ba sir, dalawa lang? It's just the electrode and the electrolyte. Okay, so between the electrode and the electrolyte, there is some sort of a surface layer. Okay, a film of solution that is happening. Okay, so if you're going to look at this, what is the overall reaction here? OX plus Ne producing, yeah. So you can see there your, let's say metal, mass transfer between the solution and the surface layer. And then there's what? A chemical reaction here. Okay, and then the physical state or a change there. And then this is where the reaction that happened. You see this reaction? Ito lang yun. Now, any of the intermediate steps shown here can limit the rate of the overall reaction. It can be this, it can be this, it can be this, or it can be this one. Okay, so if you have the mass transfer, what do you see there? Movement of the oxidized form from the bulk solution to the surface layer. When this step limits the rate of the overall reaction, we have what? The concentration polarization. Now, some half cell reaction would proceed by an intermediate chemical reaction in which the species, this and this, they form. And this intermediate is then the actual participant in the electron transfer process. Remember, they have the same form as the one that you have here. So if the rate of formation or decomposition of the intermediate limits the current, so we have here the so-called reaction polarization. Now, in some instances, okay, the rate of the physical process, such as what? Absorption, desorption, ano pa? Crystallization. Okay, so if those things happen, so they're just type of what? Polarization. And when the current is limited by the slow rate of the electron transfer, okay, from the electrode to the oxidized species in the surface film or surface what we call layer, or from the reduced species, okay, to the electrode, we have the so-called CT polarization. So that is what we call the charge transfer polarization. So this polarization can happen simultaneously or just one at a time. It depends. Okay, but I'm just trying to show you here, okay, the polarization that happened in this process. And this is what you see in electrochemical method or electroanalytical method thing. Question? So if we go to this charge transfer polarization, so this arises when you have the redox reaction at one or both electrodes that is not sufficiently rapid to yield currents of the size that is demanded. And usually it arises due to this following characteristic. There's an increase with the current density. Okay, so defined as the amperes per square centimeter of the electrode surface. Okay. Now, the over voltages can also decrease with an increase in the temperature. And over voltages that arise from the charge transfer polarization, they can vary with the chemical composition of the electrode. And we could say over voltage are also most marked for the electrode processes that yield the gaseous products such as hydrogen or oxygen. They are frequently negligible where a metal is being deposited or when an ion is undergoing a change in the oxidation state. And the magnitude of over voltage in any given situation cannot be predicted exactly because it is determined by a number of uncontrollable variables. This is, we could say, a big field in electrochemistry. Okay, so they try to study this one because one metal, they have different, we could say, polarization thing. So if you want to really undergo, or we could say go to electrochemistry, this is one field that they try to study and understand. Okay. So if you're going to look at this over voltage, usually it's for the evolution of this hydrogen and oxygen. That is where they are significant. And the difference between the over voltage of these gases on smooth and on platinized platinum surfaces, we could say, is very striking. So for a smooth platinum electrode immersed in 1 molar sulfuric acid, this is the current density, the over voltage is 0.68. But if you have a platinized platinum electrode under the same condition, the over voltage is very low. Why? What accounts for the difference in the over voltage? Anyone? Ano yung difference ng dalawa? So one is a smooth one, and the other one is a platinized one. So why is it you need a lot of this one compared to this one? Anyone? I think this is the last slide that I have. So you may ask yourself, where do you use this platinized electrode or the platinized surfaces? They usually use it to construct the hydrogen reference electrode, the SHE. Remember, they don't have metal, so they have their platinum. But the difference is primarily due to jewelry. Yes, platinum is what we call one of the noble metal. And in fact, it's much expensive than silver and gold. Diba yung pag ina-award kayo nung gold records. So kapag, I don't know, 10 times or 100 times, platinum record na tawag doon. I don't know exactly the difference, but I know platinum is much higher than gold. But the difference is primarily due to the much larger surface area associated with platinized electrode, which produce a real current density significantly smaller than is apparent from the overall dimensions of the electrode. And its main use, platinized surfaces, is in the construction of the hydrogen electrode. They usually lower the current density to a point where the over voltage is almost negligible. Kaya mababa yung ano nila. Okay? So I think that's what I have. Okay, Carmel?
Sir,
Tanong?
na-curious lang po ako. Kung mas mahal po ang platinum compared sa gold and silver, so ibig sabihin yung mga ginagamit namin sa lab, pwede namin yung ipagawa na
Meron ba kayo
singsing.
nun? Mahal talaga siya. It's
Kasi di
really
ba sir,
expensive. Yung ang ano namin dito, yung silver, hindi namin binibigay. Merong ID na inaano kasi baka iuwi nila yung silver wire. Mas mahal talaga yung platinum kaysa sa gold. I don't know kung meron kayong platinum. I think meron kayo sa platinum, ano, yung auxiliary electrode. Carbon lang. Okay, kaya naman pala. And usually, if you have a platinum, it's really a very thin wire because of the, the nature it has. But it's really expensive compared to gold. That's why, dun nga sa mga recording, di ba? Platinum, gold record na yung album or platinum, I don't know. Tapos, may umabot pa nga diamond, di ba? Hindi ko alam kung sino yung artist na yun, si Jose Marichan ata. Yeah. Kasi noon, nung nandyan pa ako, laging Eraserheads, you have already reached this, what we call, pati yung mga artista na hindi marunong kumanta, nag-gold record at platinum record, di ba? So that's just the application of the thing that you have. So question, may tatlo na nag-post nung kanilang topic and I approve it. I think si Judy, si Rodel, hindi ko alam yun, si Tristan ba yun, pangatlo? Whoever posted the one that you have, si Roland pala yung isa. Okay? So I approve ko na yung ano doon. Okay? One is in illicit drugs in oral fluid. One is in the LSB of chromium 6-3 in tea, coffee, and mineral water. And then si Judy yung sa major depressive disorder. So yung iba, October na later this week, di ba? October na pala. So mag-iisang buwan na tayo. So you should also do the what we call yung kung meron na kayong review so we can at least do the thing. Because diyan kayo magkakaano. Diyan mag-iiba yung grade nyo. That will determine your final grade. I think in the quizzes you're almost neck to neck, but in the papers that's the one that you going to what we call differ from one another. So question. Wala namang holiday, di ba? Except yung sa November. Is there any incoming long weekend or holiday except doon sa November? But I'm right doon sa Bajamos that it might cancel because I know, I don't know, it was last year or 2 years ago that they canceled the Friday for Bajamos. So tanong, we still have a lot of time. It's only 11:20. I can turn off the recording.